So closure property, that's our last property that we are going to look under it. A set is said to be closure under an operation if performing the operation on the element of the set always produces an element which is also in the set. So that's about closure. So a set under this operation performing operation on the element of the set always produce the element that's in the set. So if we get the answer that is also in the set, then it's closed. Okay. So for instance, the set A equals 1 and -1 is closed under the operation of squaring, since if you square 1 you still get what? 1. If you square -1 you still get 1, and this one is still in the operation, so therefore 1 belongs to A, so therefore this one is so closed. 1 is closed, so you can find 1 in the operation. That's what we are saying under the closure. However, the same set is not closed under the operation of addition. Okay, so 1 plus 1 you get 1. Okay, and what about -1 plus 1? Is what? 0. Is 0 here? No. So 0 does not belong to A. Therefore, 0, this one is not closed. So the set addition, operation addition here is not closed. Good. So let's for example under the closure property. The operation star is defined on the set S ABC by the table below. So where's that table below? Determine whether or not S is closed under the operation star. So this is our ninth table, and we are saying that this operation, so the operation star defined on the set S ABC by the table below, determine whether or not S is closed under the star. Okay, so you are determining whether this is closed under the star. So we can watch through to determine whether it's closed under the star. So solution, by definition, this is what A B C. Okay, so A star B. So star A, so A star B, we get what? B. That's what A star B. What do you get? B. This one, so let's say B star A, still get B. Okay, so A star B. Then B star C, we get what? A. It also belongs to S. Can again, so C star C B, it also belongs to S. Anything again. Therefore, S is closed with the real numbers, that's the operation. So therefore S is closed with the operation. Okay, so S is closed under the operation because all of this here, A B C, if you can find in this, if you cannot find, if one of these does not belongs to then the operation is not closed. If one, only one, if one, then the operation is not what? Closed. So this one is closed. Closure property. Example 2. Copy and compute the table below for the operation defined on T. This one, -1, 0, 1. By the definition, you have the definition here, A triangle B equals AB. Is the operation triangle closed of S? So this is our table. They say we should copy and compute. So please copy and complete it. So solution. This one we already have our definition. Our definition, A triangle B is equal to AB. So just pick one of. So we are solving. Let's solve for this, right? So we should copy and complete, right? So now we can pick this one as A, this one as what? B. You can pick this one as A, never as what? B. It's up to you. So my A here is what? -1, and my B is 1. So when we say that it's AB, it means -1 times what? 1. Say our A is what? -1, and B is what? 1. So just paste into the definition. Simple. So -1 times 1 is what? Yes, 1. And 1 belongs to T. -1 belongs to T. So we have here -1 belongs to here. So this one also closed. Okay. So let's check for the next. So I write it here. Another example. So mine is 0, 1. So 0, -1. I'll solve here. So 0, -1. So to me that 0 because it's 8 times B. So 0 times -1 is what? 0. And 0 belongs to T, right? 0 is here, so 0 to also belong to the set T. So let's write it here. So we are completing the table. Okay, so you copy and complete it. So let it here. So 0 operation 0. 0 operation 0 is like 0 times 0, right? 0 times 0 is still 0. Then we say that 0 is also belongs to T. We said that here. So therefore, this one is 0. Now, 1 times 1 operation 0. So 1 operation 0, yeah. It's 1 operation 1. Okay, 1 operation 1 rather. 1 operation 1. That's the boss here. So 1 operation 1, I frame it. So 1 operation 1 plus 1 operation 1. Instead that 1 operation 1 is not 1 times 1 in the definition. The definition here is what? 1. And 1 also belongs to T. So you see the acceptability here, 93. Then T is closed with respect to the operation triangle. So T is closed with respect to another operation triangle here. So this one is also closed. That's the closure property. So if any of this does not belongs to this set, then it's not closed. Then the set triangle is not closed. Okay, if one, at least one, then the set of one is not closed. So all of them belongs to here. So we are going to solve questions on the binary operation since we are done with all the operations, the properties of what? Binary operation, commutative, associative, distributive, identity element, inverse element, the closure. We are going to combine them and solve questions. So this is our first question. The binary operation is defined on the set this, and this is our table below. Okay. So what are the questions under it? Determine whether or not Q is closed with respect to the operation. So we should determine whether or not Q is closed with operation. B, is the operation commutative? Yes, you solve that one too. These are the questions. What is the identity element? State with reason whether or not each element has an inverse. Each element, whether or not each element has an inverse. So I hope you can do this one. So try it for me. So let's compare our answers, right? What are your answers? So the first question, what is it? Yes, determine that whether it's what? It's closed or not. So we said that with the closure, we said that the element here must belongs to what? Q, the set here. So let's see that the element here, all of them belongs to the set here. 2 is there, 3 is there, 4 is there, 5 is there, 3 is there, 4 is there. 1, is 1 here? No. So meaning this operation is not closed. But since we have 1 here, so that's Q is not closed with respect to the operation since 1 is not in the set Q. Okay. And our second one was what was our second question? Yes. Good. So we should tell that the operation is commutative or not. Yes. With here, are you going to do it one after the other? How are you going to do it? It's commutative. So please, the operation this is not commutative. Why? Since elements are not symmetrically placed about the leading diagonal. How? Let me help you here. You see, this is our leading diagonal, right? This is our leading diagonal, right? 4, 2, 1, 4. This is our leading diagonal. This is the diagonal. Okay, this is what we are saying. The leading diagonal. It's not the leading diagonal. And we are saying that since the elements are not symmetrically placed above the leading diagonal, so apart from this my leading diagonal 4, 2, 1. Okay, so this is what I'm saying. My leading diagonal. Good, right? Now we are saying that from here we have what? 3 is here. That's what symmetrically, are not placed symmetrically. So are not symmetrical placed about the leading diagonal. We have 3, 4, 5. Here we have for 3, 1, 5. No. We have 4, 5. What here? 5, 2. They are not the same. 3 is here. So this is what we are talking about. We are talking about the symmetrically. So we are talking about all the elements here. All the elements here. So we are saying that all the elements here, all the elements here should be the same here. Okay, that's what we are saying. So the leading diagonal, the element here should be the same here. So like we said, 3, 4, 5. And we have 3, 1, 5 or 5, 1, 4. Are they the same? No. So that's what we are saying. So this shows that it's not what? It's not commutative. So since elements are not symmetrically placed about the leading diagonal, that's what I'm saying. And our identity element, yeah, our identity element is 2. Why? We know how. So let's check the first column and the second column. The first, sorry, the first column, these are column, right? And the first row are the same, they repeat. So our first row, this is our first row, they repeat. This one, the same to repeat here. So therefore, the identity element is on 2. You say 2 star 2. So which means the identity element is on 2. So therefore, identity element is what? 2. Okay, if it were 2 star 3, if they repeat, then identity element here will be what? 3. Okay, so our identity element here is what? 2. That's as easy as that. That's how we watch it. So the first row and the first column repeats, therefore it's happening on 2. So identity element is 2. And you talk about the inverse, say inverse of each of the elements. So let's go. A operation 2 is what? 2. Okay. Then we know that we should find out the inverse element rather. So A operation, the answer one is 2 because the identity element is what? 2. So we said that the inverse A operation, the inverse of A, you get the identity element which is 2. So let's go again. What is 2 here again? There's 2 here. So therefore 3 operation 5 is what? 2. That's why it's here. And what again? 4 plus something to give us no. So 4, there's no identity element, there's no inverse element here. This one here, there's no 2 here, no 2 here. So that's the only for the inverse element. So we have only 2 inverse elements in the operation. So the element 2 and 3 has an inverse, right? So the element 2 and 3 was 2 and 3, but it's the inverse of 2, the inverse of 2, but the inverse is 2. So the element 2 and 3 has an inverse, but element 4 and 5 has no inverses. Okay. Our second example on solving questions on the binary operation on all the properties that we have done so far. So this is our second question. Okay. So I'm normally solving the table one. Fine. Give reasons whether the following are correct. I. Y is closed with respect to the operation. Okay. The operation sign is commutative. There is an identity element. There is an identity element. So we will find out. B. Fine. Where possible, there is inverse of the element R, S, T, and U. C. Find P and Q if I, U operation R bracket Q plus T operation T equals this. So we are going to solve for it. So please pause the video and start solving. Then we compare our answer. Okay. Okay. Let's compare our answers. Okay. So this is our table. And I, the A, the question said, find, giving reason whether the following are correct. Okay. And we say I, Y is closed with respect to the operation. So let's say that Y is closed. We say about the closure property. All the elements here must belong to what? The set Y. So we are saying that all elements are belongs to. Then you can see that it's closed. You have R S T U. So R S U R T S U R T. So what is this? This one you will know. So Y is closed with respect to what? The operation. So Y is closed is true. Since all the elements of the table are in the set Y, Good. That's good. And our next question is the operation commutative? And what is about the commutative? Yes. Hello. Okay, so let's compare our answer. So our symmetrically placed about the leading diagonal. And our previous example, the question we said that there is no communicative when they are not symmetrically placed about the leading diagonal. The operation star is commutative because since the elements are symmetrically placed about the leading diagonal. So we said that this is our leading diagonal, right? We said this is our leading diagonal. This is what we said earlier. These are diagonal, right? And we are saying that the operation symmetrically about the diagonal. At first, it was not, but here, let's see whether is it. So we have URT. So we come here, we have for URT. So they are the same, right? Okay, let's move on. The second one, we have SR, SR, U, U. So meaning those here are the same as here. That's what you are saying, that since elements are symmetrically placed about the leading diagonal, so therefore this operation is commutative. Good, right? And then the next one is there is an identity element. So we should check whether there's an identity element. In our previous video, said that the identity element is at first said the first row and the column they repeat. So here, let's check that we are identity element. So let's check about the first row. SURT. They repeat here because this one we have for RSTU. SURT. So this one there does not repeat because there's no R here. It's SRS. No. So this one is not dot. So it's supposed to repeat like SRSTU. Okay. So here is S. So no. U. No. We have R here. Okay. We have R. So meaning we have R S T U. So the same here. So this column. So this column repeats here. So this column it repeats here. Okay. That's what we are saying. Now let's check. So this is the so how many column? 1, 2, 3. That's the third column. 1, 2, 3. The third column repeat here. So let's check the third row. So the third row we have for RSTU. So it's the RSTU. So meaning the third column and the third row repeat itself. So then it means that the and it happen on what T, right? It happen on T. So the identity element is T. The third row and the third column repeat. So the identity element is what? Is T, right? So our T is identity element, right? B from the table. So B, we should find where possible if there is an inverse element. Since we know our identity element, we can find our inverse what element, right? So identity element is T. So our inverse element, you have T here. So which means R operation U, which will give us what T, right? We know that as for the inverse, the answer we get is what? The identity element, right? So that is U is the inverse of R. Okay, U is the inverse of R. And here we have T here. So S, that's self inverse. Okay, S operation S give us T, meaning it's self inverse. Okay, S is self inverse. And here we have T here. Good. So T operation T is T. That's identity element because identity element is T. That one too is self inverse. And we have U operation R. This one, U operation R is T. Then that is R is the inverse of U. As easy as that. Let's solve the last question. That's the C. So this is our table, right? Subscribe to Senior Fellows, my YouTube channel, for more videos. So with this, let's compare our answers. So the solution here, this is our first solution, right? And so in our table, U, the operation sign here, R. So U operation R. Where is U? Our U here, U operation R is what? T. So that's our T, right? Then the operation sign will come. Then T operation S, that's our S. So T operation sign S is S. So that's our S equals our P. It was want to find P. Therefore, T operation S again. Oh, okay. So it's S, right? We check it's S. So that's P. Therefore, P is equal to S. Good. Now with the II, that's where the trouble is from. Okay. We don't have Q operation. I don't have Q here. So let's go and solve this one first. T operation U. So let's move on. We don't have this one. So T operation U is U. T operation U is U equals to S. Since don't have Q, so now that U operation what will give us S because don't know Q, so it will give us. So ask ourselves, U operation what will give us this S. So let's come to U. We have S here. Okay. So meaning U operation U will give us S. So meaning U operation U will give us S. Therefore, Q operation out is what? U. Yes, Q operation R is U. Right? Then since we don't know Q, so ask ourselves, R operation what here will give us U. So let's move to R. We have U here, meaning R operation S is give us this U. So S operation R, S operation R is what? U, right? S operation R is U. So then therefore can be that S is equal to what? Q. So therefore our Q2 is S. As easy as that. Subscribe to Senior Pelus, my YouTube channel. Like my videos for more videos, okay? Bye bye.